Okay. Gabby decided she was going to come and visit for Math 12. Hi, baby. Yeah. Wicked's downstairs, mad that he's not up here. All right. So nobody asked me any questions on section 8.5, the last example I did. And I've already gone over the first two examples. I'd already gone over questions from that. So I'm headed straight into section 8.6, which is all trig, which for me is very happy. I don't know how you feel about it, but for me, when I get to do trig, I'm very happy about that. So today's lesson is going to be quick, simple, easy. Life is good, all right? And if you're in physics, even better, because we've been doing trig right along throughout different questions. Well, it's a whole party up here. I've got 3 dogs around my feet now. So there's 3 things we're going to talk about in this section. So remember I said there were 3 things in the last section. There were 3 types of questions. The first type of question was if you have a circle and a line through it, finding the places where the line and the circle cross. If you've got a circle and a tangent line, finding the equation of the tangent line. And if you have a point way outside a circle, what is the length from the tangent to that point? Those were the 3 things. Well, there's 3 things in this section as well. There's going to be straight SOHCAHTOA, sine, cosine, and tangent, when you have a right angle triangle. Then, if you don't have a right angle triangle, using law of sines and using law of cosines. 3 things, all right? So, the first thing we're going to look at, and the only thing we're going to look at today, is SOHCAHTOA. Hopefully you all remember SOHCAHTOA. Again, if you are in or were in physics, we were doing that quite regularly. So it should be pretty fresh in your mind. But we only use SOHCAHTOA. We only use sine as opposite over hypotenuse, cosine as adjacent over hypotenuse, and tan as opposite over adjacent. We only use those when we have specifically, this is a nice blue, specifically a right angled triangle. If the triangle is not a right angle triangle, then don't try and use sine as opposite over hypotenuse. Because if you don't have a right angle triangle, then you don't have a hypotenuse. So you can't use it, all right? So SOHCAHTOA, which is just sine is the opposite side over the hypotenuse side. Cosine is the adjacent side over the hypotenuse side. And tangent is opposite over adjacent. We did this in grade 9. You did it in grade 10. We're doing it again in grade 11, all right? So we're going to be basically solving a triangle, which means finding all the angles and all the sides that they don't give us. There are many ways to do a single question. There are many ways to do a single question. So you might do it differently than I do it, but still get the right answer. As long as you show me your work so I know what you did, as long as what you did is logical, it's fine, okay? So the example on page 494 that we're gonna do gives us a triangle and it labels it X, Y, and Z, all right? Remember that angles are always capital letters. So capital X, capital Y, and capital Z. The side opposite the angle. So if this is angle Z, this is side Z. And it's represented with a small letter. If this is angle Y, this is side Y. And if this is angle X, then this is side X. The side opposite the angle is always the lowercase letter of whatever the angle is. So In this triangle, they tell us that this is 90 degrees. Obviously, they put a right angle sign in it. And they tell us that angle Z is 42 degrees. And then they tell us that this side over here is 8.4 centimeters. And what they want us to do is they want us to find all the things that we don't know. So they want us to find angle X. They want us to find side Y. And they want us to find side X. So there are three things we need to find. How you go about doing that will be up to you. I'm going to do it once one way, and then I'm going to do it a second time a totally different way, so you can see that there's more than one way to do this, and even the two ways I do it would not be the only two ways to do it. So I'm going to do it the way I would do it if this were me. I'm not even looking at the textbook. I don't care what the textbook did. I'm going to do this as if this was a question given to me. So if this were a question given to me, the first thing I would do is I would find angle X, because I think it's the easiest one to find. And I know that all angles in a triangle have to add up to 180 degrees. So if they all have to add up to 180, and I know that angle Y is 90, and I know that angle Z is 42, if I just subtract those from 180, what I will have left is angle X. So 180 minus 90 minus 42, and that is 48 degrees. So I've already found angle X. Angle X is 48 degrees. All right, so now I need to find another side, and honestly, I don't care which one. This one's right here, so I'm going to do this one. If I want to find side Y, now I now know that this is 48. However, I'm not going to choose to use 48 in my calculation for this, and here's why. If I happened to make a mistake in figuring this out, and then I use this number to figure this out, that will make this one wrong too. So I tend to not use something that I figured out, and I tend to try to mainly use things that were given to me in the question, just in case I made a mistake. Now, if you are confident that you did not screw it up, and you are confident, you know for sure that you got that 48 right, then go ahead and use it if you want to figure out something else. So side Y, here's what I would do. I would say, listen, if this is my reference angle, if this is the angle I'm going to use, I know this side over here, which would be opposite this angle, and I want to know this side over here, which is the hypotenuse. If I have opposite and hypotenuse, that means I should be using sine. So I would say that the sine ratio of my 42 degree angle is the opposite side, which is 8.4, over the hypotenuse side, which is y. Now I would just rearrange this. I want to get the y by itself, so I'm going to multiply this side by y so that they cancel. So I'm going to multiply this side by y. So now I have y times sine of 42. And if you wanted to, you could go to your calculator and put sine of 42 and change that into a decimal. I don't bother. And that's equal to 8.4. Now again, I want to get the y by itself, so I'm going to divide this side by sine of 42. So I'm going to divide this side by sine of 42. So I'm going to go to my calculator, and I'm going to put 8.4 divided by sine of 42. Now, for those of you who hate showing work, if what you show me is that you did y is 8.4 over sine of 42, I just need to see what you did. What did you put in your calculator to get your answer, so that I can figure out what it was you were thinking when you did it, all right? So if I go to my calculator and I put in 8.4 divided by sine of 42, that gives me 12.6 because they said round to the nearest tenth and it was 12.55. So I rounded it up to 12.6. All right, so now I know this side is 12.6. I need to figure out side x. Again, there's a bunch of different ways I could choose to do that. I'm going to do it this way. I'm going to stick with this number because they gave it to me. And I'm going to stick with this side because they gave it to me. That's opposite, but I want to know this side, which according to this reference angle would be the adjacent side. So opposite over adjacent would mean tan. And so I would say tan of 42 is the opposite side, which is 8.4, over the adjacent side, which I don't know. I would use the same logic as I did over here. I'm going to multiply this side by x, so I'm going to multiply this side by x. So I have x times tan of 42 is 8.4. So I would divide both sides by tan of 42. So I'm going to do 8.4 divided by tan of 42. So I'm going to go to my calculator and I'm going to do 8.4 divided by tan of 42 and I'm going to get 9.3. Now remember, when you figure this out, your hypotenuse side should always be my longest side. So I just do a quick check to go 8.4, 9.3, hypotenuse 12.6. Okay, well at least it is the longest side. So that's one way to figure this out, okay? That's one way. That's the way I would have probably done it. But let's say that's not how you did it. Let me show you that there are different ways to do this. So I'm going to do exactly the same question. I'm even going to leave the answers up here just so that you can see that I'm going to get the same answers. But I'm going to do it slightly differently. All right. So let's say this time, instead of choosing to find angle x first, let's say I choose to figure out, well, let's say I choose to figure out, let me see. I could choose to figure out side x. Let's say I chose to figure that out first. I probably would figure this one out if I had to figure out side x. I probably would figure this one out exactly the same way I did it before, because I really only know this, and that's all at this point. Because remember, this and this and this is all stuff I'm going to figure out. So at this point, I'm assuming all I know is this and this. So if I decided to figure this one out, I would probably do exactly what I did before, and I would say tan of 42 is opposite over adjacent, and I would solve exactly how I did and get 9.3. But if I started there, maybe this time what I would do is I would say, listen, I'm really confident in my answer. I'm really confident that that is 9.3. And so now I know this side and I know this side, and I want to know the hypotenuse side. And I know that the Pythagorean theorem is a squared plus b squared equals c squared, c being the hypotenuse. And so if I'm really confident that I got that right, I could do that this is 8.4 squared plus 9.3 squared equals c squared. And so I'd go to my calculator and I would do 8.4 squared plus 9.3 squared is 157.05, but that's c squared, so I'm going to take the square root of both sides. So if I do the square root of my answer, I get 12.5, rounding it off. Now again, last time I got 12.6. It's fine if it's different by about a tenth, because it really does depend on, because technically this is not 9.3, it's 9.3 and it keeps on going and going and going, but I've rounded it off to 9.3, which throws this off a little bit. I'm going to know that when I follow through your work. That again, that's why you have to show me your work. And I'm going to go, that's okay. All right, so now we need to figure out angle X because we in theory don't know that. And say I forgot that all angles in a triangle add up to 180. I need a different way to figure it out. I could do that. Again, assuming that I'm confident in my answer, I could do that I know the, and again, if I'm now looking for this side, right? If I'm now looking for this angle. If I'm now looking for this angle, this side is now adjacent, right? It's no longer the opposite because I'm now using this angle as my reference angle. But this side is still the hypotenuse. So adjacent and hypotenuse would be cos. I'm choosing cos because I don't think I've used it yet. So I would say that cos of angle X, so cos starting from this angle, which I don't know, is the adjacent side, which is 8.4, over the hypotenuse side, which is 12.5. So when you're trying to figure out an angle, I'm going to move the cos over here, but it becomes, it's called arc cos. It's that cos to the -1. So on your calculator, you're going to have to hit shift or second function or whatever your calculator button happens to be. But it's called arc cos, A-R-C, arc cos is what that's called, but it's that cos to the -1. So I'm going to hit shift cos, and in brackets, you can't make that a fraction. You can't put 8.4 over 12.5. Calculators don't like decimals in fractions, so I'm going to do 8.4 divided by 12.5, all in brackets. And I'm going to hit equals, and it says 47.7, but they want me to round angles off to the nearest degree, which is going to round off to 48 degrees, which is what I had before there. So I just did that question twice. I did it once one way, once a different way. Doesn't matter to me. As long as you are following the right rules, I don't care. Just show your work and make sure you use SOHCAHTOA appropriately. All right. That's all we're going to do today. We are going to do law of sine and law of cosine on another day. So I'm going to give you a few to try just with SOHCAHTOA. And then we only have law of sine, law of cosine left, and we're going to do a quick test on section 8.5 and 8.6, and then we just have chapter 9 left to do. So have a good day. I'm going to try not to step on a dog.